Morning. GeoBuild is about building layers of knowledge. It is about interoperability. It is about finding all the information about a specific location. It is about a national approach to information. It is an exchange framework that digitises building, geographical and environmental data and information which is made available online. The challenges in the building sector are multifaceted. Sector productivity is low and it is continuing to decline. The construction sector has multiple rich sources of information, but they are disparate. Everybody is doing their own thing and we need to collaborate. We need to get the right information at the right time to the right person. Why are we doing this? Because the size of the prize is $1.5 billion per annum. A 10% increase in sector productivity in building construction will deliver a 1% contribution to GDP. That's $1.5 billion every year. GeoBuild supports and accelerates the realisation of this prize. How are we going to do this? By bringing the three initial components of GeoBuild together: building information modelling, online consenting, and location information, and ensuring that they are all interoperable. Each component delivers individual value in its own right, but the benefit of bringing them together adds greater value and generates opportunity. To the best of our knowledge, there is no other jurisdiction that has achieved this level of interoperability at a national level in the building sector. The outcome is better location knowledge.
I think GeoBuild is something that we are working our way towards. I think there'll be a number of layers that build up as we progress.
It's a very big picture concept. I think if it can be pulled off, it'll be fantastic.
I think it's very exciting that you have a national initiative focused on enabling the construction industry and the investment in construction to be given greater certainty by bringing all the pieces of information together.
GeoBuild has two main strategic outcomes: to create a national information exchange framework and to promote open access to built environment information. The flow-on effect is richer information about our whole environment, enabling better, more sustainable and resilient built environments.
For Mainzer was a construction company, a lot of industries will have a prototype of a product before it goes into manufacture. A bit hard to do that with a building. Your prototype product, if you like, is your finished product. So being able to do it in 3D, we can build something in the computer, iron out all the wrinkles, find all the problems before we go to site and actually build our finished product.
Built environments can be created in the virtual space and tested for sustainability, resiliency and many other scenarios.
Designing with 3D software is less forgiving. It encourages you to make more decisions up front. The later you make design changes, the more it costs you. So what BIM does is it makes you look into those decisions at a much earlier stage.
One of the core components of GeoBuild is accelerating the adoption of building information modelling. As mentioned in the clip, 3D design software is less forgiving. It encourages you to make decisions up front. This irons out the issues on the desktop, not during construction. Rework and cost is reduced and productivity increases.
The GIS systems which are starting to appear on council websites and across the country are going to become more and more important to the building industry and in particular designers. At the moment you have contours, you have sewerage, you have stormwater pipes, you have aerial photographs, you have information that would identify the rates, the CV of the site. All of those things can be accessed onto the GIS system. What we don't yet have is, for example, the town planning drawings overlaid onto the GIS system. But I don't think that's too far away. You can easily picture how that might happen.
Another core component of GeoBuild is the referencing of that knowledge to a location. As we all know, knowledge becomes easier to consume and understand in a spatial context.
The challenge, in a way, for the industry is making sure all of the output files from these pieces of software can all talk to each other, and we do achieve an interoperability across the industry.
Interoperability is king. Building information data needs to interoperate with the location information, both of which need to interoperate through the consenting system. The opportunity here is to capture the rich building and location information, reuse it, layer it, apply it in different contexts. To demonstrate the power of interoperability, we've created some 3D models for you. The difference is that these are not fictitious mock-ups. They use the Auckland virtual city created by NextSpace, the actual BIM model that Mainzeal used to build its head office, as well as other real data sources. So you can prototype a building if you have the relevant information in the right format. Again, this comes back to interoperability. In the case of the Mainzeal building here, they took many months to gather the required data, often using specialist researchers before they even got to building the plan. The data had to be normalized before they could even use it. Here we see a brownfields site inspection for the building. Understanding the previous use of the site gives us insight into the new design and any restrictions we may have to overcome. Often what is underground, the geophysical, geotech, or the infrastructure, is not readily apparent, yet it can prove to be a significant contributor to project delays and cost overruns. Here we see functional use of the building being analysed. In this case, we're using an adjacency matrix for the areas of the building. Understanding the intended use of a building and being able to model it allows us to adjust in the design phase, to look at the interactions of those spaces, to understand how things will flow. This results in more user-friendly, productive environments. Now we look at some of the planning considerations, such as view shafts in Auckland and sun planes. In this case, the Mainzeal building, as you can see, is in the E10 view shaft. But from a three-dimensional perspective, its height does not actually intrude on the view shaft. This information, the view shaft, sun plane information, have all been manually imported into the model. It's all real data. But what if the data was readily available in a standard, open and interoperable format? That you didn't have to customize and build these models and manually import. What if it's there already, open for you to consume? A major management issue for building projects is the management of cost and time. This is sequencing the building in terms of its construction. And we can see the phases that are going through here. And this is your cost curve running up here. So this is actually how they built the building. In the model, we can scenario out the construction process with reference to the phases of the project and this cost impact. This scenario modelling offers efficiencies in procurement sequencing and cash flow management. Having materials sitting on site that won't be used for a couple of months is not good use of your cash. When it comes to building consenting, we can overlay the building code. We can identify individual building elements and the area of the building code that applies to that element. We can focus in, and where the building control officers can then assess the plans in 3D in that virtual environment and make more informed assessment before issuing consent. One of the other advantages of these sort of tools is the collaboration. So you have the relevant experts that can participate in this conversation in the 3D virtual space. But what are the other possibilities? What if, as council, your contractors can use their GPS-enabled tablets to accurately identify the services underground before they dig? Maybe you could line up all your contractors at the same time. As a ratepayer, I would enjoy just digging the road up once. It's like Wellington Council there, haven't they? Sorry. Another possibility. What if, as an emergency responder, you're going to a situation, as you enter the building, you scan the building's QR code with your tablet, and then you enter the building. You get an augmented view of the building, identifying concealed infrastructure. You can see what's in the building, where the pipes are. You can see hazardous materials. You know, as a firefighter, if the fire is burning in a particular room and you know that it's heading towards some sort of flammable combustible area, you can take the appropriate action. Our killer app. So from a building and housing perspective, what can we do? This is a national online consenting system. One system across the country that is interoperable with council systems. The system will interoperate with the building and location information. Building and housing, part of MB, are looking at a phased rollout of this national online consenting portal over the next 2 to 5 years to try and pull all those data sources together to drive those efficiency and effectiveness gains. Every council we have spoken to, and we've spoken to virtually all of them, has indicated their support, many wanting to be early adopters. From a New Zealand perspective, it's really a no-brainer. It's just got to be a single system. Our economy isn't big enough to support separate online consenting, disjointed building information modelling. We've got to join it up at all levels. It makes sense from a skills perspective, an economic perspective, a resource perspective, etc.
The RMA process, the building consent process, is a great consumer of time and uncertainty. If we can therefore have a virtual representation of what can be built as of right within the constraints of the RMA and the builder consents, it means you can actually put forward the proposals with knowledge that that can be an unnotified approval because it complies with existing legislation requirements. And that will save months off of the whole procurement life cycle.
As you can tell, Peter Gom, Chief Executive of Mainzil, there's great interest in the construction industry in this. It drives a lot of efficiency, it drives a better bottom line for them. And a lot of the constructors are already using it. We need to get joined up. So looking at some of the nuts and bolts around getting the online consistent, getting that interoperability component working. We need to establish and maintain a kernel of interoperability as a core requirement. And I say kernel because, yes, it will be standards-based, but it will be just enough. It will not be overly burdensome. It will enable government to step in and be a catalyst, but not restrict the market. We need to tread lightly in this area and be effective. As more data is added, and there is increasing richness, it delivers greater and greater value. And of course, with better open, standard and reusable data, we're creating increasing levels of opportunity within the market itself. Opportunities that we can't foresee. Silos equal isolation. Interoperability equals collaboration. So as we start to layer, we can pull in information Thank you, Alex, for your previous presentation. There's a wealth of information out there from various different providers. And it's about layering that information, being interoperable with those layers. The whole is greater than the sum of the parts, with a foundational layer of interoperability. We build the complete picture, a collaborative vision, location-based information. Looking at some of those opportunities, we've already seen multiple examples through this summit of where information can be applied in very, very innovative ways. The central picture, when we're looking at having your 3D plans on your tablet, going to your section, holding it up and seeing what your house looks like. It's there, we can do it, we just need to be interoperable in the data. Within the built environment, GeoBuild will create many, many opportunities. The market will demand and deliver yet unknown application and uses for this knowledge. Now, apologies, this next one's a little slow in how it runs. But again, courtesy of NextSpace, thank you, Richard. Sponsored by NextSpace. But this was just a good example that I thought demonstrates when you've got your three-dimensional model and you're looking at it on your tablet, representing it. Imagine the backdrop, you overlay your camera, the backdrop of your actual section. From a GNS perspective, the bit I like, once he turns it around. Is starting to look at the underlying soil types, where the bedrock is, being more informed about, when you're looking at your site. So it's about pulling this information together, the interoperability of it, and the consumption of it. Where can we deliver value? The even bigger picture is the other perspectives. Interoperability allows layering of data sets on the underlying location-based fabric. We can look at the information through different lenses, different perspectives, and gain different insights if we're working off this interoperable layer. In the health area, for example, you could overlay the address of children suffering from rheumatic fever to identify unhealthy homes. Or is there a below ground water condition that's affecting the dampness of the home and causing illness? GeoBuild isn't a thing. It's about interoperability. It's a quality mark of interoperability. It's permission to play in the game around the built environment. What is the endpoint? There is no endpoint. As our knowledge base expands and the ways we access this information evolves, GeoBuild will continue to grow and change to meet the needs of the market. So I'll just leave you with some final comments from Greg Boyden of Jasmax.
Traditionally, we have had a little bit of a silo mentality. So, for example, the standards, the New Zealand building standards are produced and you've got to go to one website. If you want to find out information about the atmospheric conditions on your site, you've got to go to another website. So how that all pulls together into a central database is, I imagine, quite a task. But if you can picture that it will happen and the country is committed to it happening, then I think it's a very exciting prospect. And the nice thing about New Zealand is we're often small enough that we can achieve these things quite quickly once we set our mind to it.
And just a final word, thank you to Andrew and Stephen, part of the GeoBuild team, for helping me with the presentation. Thank you.